Here we go again. Good morning, everyone. So on Thursday, we went over solving systems of equations using the substitution method. Today, we're going to be continuing our work with solving systems of equations. This time, we're going to be using the elimination method. So our topic of today is solving systems of equations algebraically. Our learning target. Today, I can solve systems of equations algebraically by using elimination. Problem number 1. Use elimination to solve the systems of equations below. We have negative x minus 7y equals 14 and negative 4x minus 14y equals positive 28. So, step number 1, you have to make sure your equations are written in the same form. I can see my x terms, my y terms, and my constants all aligned. So, yes, we move on to step number 2. Step number 2, you want to get an additive inverse. Let me write this down real quick. Additive inverse. So let me remind you guys what an additive inverse is. An additive inverse are numbers that add to, of the opposite sign that add to 0. For example, negative 4 and positive 4. Or you could say negative 1/3 and positive 1/3. The numbers are the opposite signs, and when you plug it in your calculator and add them together, you would get 0. So, I look at my two equations and I see that I don't have additive inverses. So, to get additive inverses, I have to ask myself what two numbers are factors of one another. I see this negative 7 and I see this negative 14. I know that 7 is a factor of 14. So my goal is to get this negative 7y to turn into a positive 14y. So that it is the additive inverse of negative 14y. I do that by multiplying my top equation by negative 2. Because negative 2 times negative 7y will give me positive 14y. Remember, when we're doing this step, you multiply it to everything in the equation. Negative 2 times negative x is positive 2x. Negative 2, oh my gosh. Is the ambulance serious right now? Anyways, negative 2 times negative 7y is positive 14y. Bring down my equal sign, and negative 2 times positive 14 is negative 28. Then I take this bottom equation and bring it down. Rewrite it down here. I have negative 4x minus 14y equals positive 28. We immediately eliminate our additive inverses because they will add to 0, so it makes no sense to rewrite it. 2x minus, and then, Miss Price, come on. We're on to step number 3. We have to combine our two equations. We combine our equations by adding them together. 2x minus 4x, 2x plus negative 4x is negative 2x. Again, we eliminated that, so we bring down our equal sign. Negative 28 plus positive 28 is 0. Our last step, we divide our coefficient because we want to solve for x. And x equals 0 because 0 divided by negative 2 is 0. Alright, so we know that x equals 0. And we know that negative x minus 7y equals 14. And now we want to solve for y. We know that x equals 0, so we're going to take that 0, substitute it, and place it as x down here. So we have negative 0 minus 7y equals 14. We could rewrite it without the 0 because anything adding 0 plus anything is itself. So we have negative 7y equals 14. Divide your coefficient on both sides. Because we're solving for y, and we have y equals 14 divided by negative 7, which is negative 2. So, when you want the solution of a system of equations, it is always the point at which your two lines intersect. So that means a point is written as an ordered pair. So our answer should always be in the form x comma y. We made this mistake last Thursday. If you guys don't fix it, I'm going to take points off of your classwork. So our solution to this system of equations is 0 because our x is 0, comma, -2 because our y is -2. Okay, so here goes your problem 2 of the day. Take a screenshot, write it down, solve it, and answer it in your classwork. Have a good day, guys.